Hi, I'm Boris. Thank you all for coming to my talk today. I'm a founder and a software designer at Code Synthesis, a company where we try to build interesting open source tools and libraries for C++. Some of you might have heard even use some of them, such as XSD and ODB. The topic of today's presentation is XML in modern C++. Those of you, I thought there was a question already. Those of you who didn't have a chance to handle XML in C++, by the end of the talk, we'll have a pretty good practical understanding if you need to handle XML in your next project. By the way, is there anyone here who was lucky enough not to have to deal with XML in C++? A few lucky ones. Cool. Well, the rest of us, those that try to handle XML in C++, probably know that things are pretty bleak. There's no XML support in the standard library. There's no XML library in Boost. And existing libraries at best have APIs that are non-idiomatic C++. Well, and at worst, look at Xerces. As we will see in a moment also, quite a few of the new claim to be fast and compact XML libraries for C++ actually don't even provide real, as in conforming XML parsers. So the goals of today's presentation is to try to change that by presenting an API for a simple API for XML that was designed with the most common use cases rather than what other libraries for other languages might have. So the outline of the talk is as follows. First, we'll spend a bit of time on general XML-related topics, such as why we use XML, some terminology, some related technologies, what it takes to build a real XML parser, as well as common XML processing models and APIs. I'll also touch a bit on existing tools and libraries for handling XML in C++. The bulk of the talk will be dedicated to figuring out understanding the common XML usage patterns in real C++ applications. Once we have that, I'll then present an API that was specifically designed with these use cases in mind. Also show quite a few concrete examples of its use. And then I hope you'll give me your feedback. At the end of the talk, I'll also spend a bit of time on implementation-related details in case you would like to start using the new API. Okay, but first, why would you listen to this guy? Well, the past 10 years, I developed and maintained a tool called Code Synthesis XSD. It's an XML data binding compiler for C++. If you don't know what XML data binding is, let me put it this way. If one day you find yourself having to handle a large XML vocabulary in C++, XML data binding is what will preserve your sanity. In fact, when we released the first version of our tool, mental institutions were not amused. Seriously though, I'll explain what XML data binding means later in the talk. Yes, first question. Thank you. So the comment was that Eric used Code Synthesis XSD and he thinks it's awesome. Glad to hear that. Cool. Yeah, and in this past 10 years, I've also seen some pretty sick stuff. If you think a vocabulary with a couple of thousand unique elements is uncommon, think again. So here's the quick question to test your XML knowledge. Who do you think publishes the most badly designed and often outright broken XML vocabularies? We have the winner.
We have a plant in the audience. Two counting here.
So yeah, the answer is W3C. Okay, so why do we use XML? In fact, we can divide everyone who knows what XML is into roughly 3 groups depending on how they feel about it on any given day. The first group thinks it's a pure evil, and the middle group thinks it's sometimes the right answer, and the last group thinks it's the best thing ever. Well, my view of XML is the pragmatic one. I think we should use XML for data interchange and not just data as a data storage format. After all, if your application is the sole producer and consumer of XML, then you might as well choose a format that is more efficient and more natural for your situation. XML is best suited when your application data needs to be accessible by third-party tools that haven't yet been written using languages and platforms that don't yet exist. So, to put it another way, the guiding principles for choosing XML should be accessibility, tooling, and education. XML has another interesting property, and that is it is human readable and writable. This can be useful sometimes. Well, it's not fun to read and write, especially the right part, but it's possible. So let me give you a concrete example where I found this useful. In another project that I work on called ODB, we needed to store database schema evolution changelogs. ODB maintains changelogs fully automatically, so it's the sole producer. However, some third-party applications in the future may need to read changelogs to do some analysis. But the most important requirement was for the user to be able to review a diff of 2 changelogs in order to see what has changed. So these 2 requirements made XML a pretty natural choice in this case. This pragmatic attitude towards XML also translated to the goals I had when designing an API. I wasn't trying to design an XML framework that will make your application revolve around parsing XML. Rather, I wanted to have a simple and convenient API that will get us away from the XML-ness of things as fast as reasonable. After all, we want to program in C++, not XML, right? When it comes to the implementation, I wanted it to be open source, portable, compact, and external dependency free. In other words, a library that you can use on pretty much any project on any platform without much fuss. This would also make it suitable as a base for something like Boost XML or even standard XML. Let's now spend a bit of time on terminology so that we know we're on the same page. When I said XML format earlier, it was a bit loose. XML is actually a meta format that we specialize for our requirements. That is, we say which element and attribute names we'll have, what the order of our elements will be, what they will mean, and so on. So this specialization of XML is called XML vocabulary. Sometimes, but not always, when we parse XML, we store the extracted data in the application's memory. Usually we would create classes, C++ classes that correspond to our vocabulary. For example, if we have the person element in XML, then it would be natural to have a C++ class also called person. So these classes we'll call the object model. When you see enough XML vocabularies, you will notice that there are 2 common kinds: data-centric and document-centric. In data-centric vocabularies use XML as just a medium for storing the data. They have a very regular structure, and the order of the elements is usually either fixed or doesn't carry any semantic. In contrast, document-centric vocabularies have less regular structure, but it's usually as important as the data itself semantically. So the examples of document-centric vocabularies would be, for example, XHTML. The majority of XML vocabularies in use today are data-centric, which is quite ironic considering XML's origins. The content of an element in XML can be empty, can be text, can be nested elements, or some mixture of the 2. So these are called empty, simple, complex, and mixed content models in XML. Okay, that's it for the terminology. XML spawned quite a lot of related technologies and standards, so let me cover the most widely used ones briefly. In fact, I divide all the XML-related stuff into 3 groups. The first group, we have the sometimes useful things such as the core XML itself, namespaces, XML schema, and XPath. I'm sure most of you are familiar with XML namespaces. They allow us to qualify names to avoid clashes. XML schema allows us to formally define our XML vocabulary. In fact, from all these standards, I believe it is the most useful and powerful related technology. It's complicated and ugly as hell, but it allows us to verify that what we are actually dealing with belongs to our vocabulary. This can simplify parsing tremendously. Even more importantly, once we have the formal definition, we can use tools to automatically generate our C++ classes as well as parsing and serialization code. This is XML data binding in a nutshell. Any questions here? Yes?
Can you spell out what's the difference between XML vocabulary and XML schema?
XML vocabulary is our specialization of XML for a particular, sorry, maybe, should I repeat the question? Okay, so the question was, what is the difference between XML vocabulary and XML schema? XML vocabulary is more of an abstract thing. It's basically our use of XML for a particular business function or logic or application. So for example, we describe a person, we say, the root element will be person, inside they will have name, age, and gender elements, and they will have such and such content. That is XML vocabulary. We basically specialized XML for our needs, while the schema is a formal definition of this vocabulary. So we basically describe that there is a root element called person, and that it will have first name, last name, and age elements and stuff. So schema is a language that allows us to formally describe our vocabulary. Okay. XPath allows us to get to a fragment of XML using a path-like expression. It can be quite handy if you need to get to a tiny bit of data deep down in the element hierarchy. Then we have the special set of standards out of W3C, of course, that are completely useless. I'm not going into detail on this because nobody really knows what they are for. And the third group is what I call life with XML. Here we have things that assume, your life should be all about XML. So I'm not going into detail on this either.
So
Question?
one question on X include, because is there some other way to include other sub-documents than X include?
Okay, the question is there any way to include one document into another rather than using X include, because it seems that's what it was for? Well, kind of the long answer is X include kind of works until you start using schema, at which point it all breaks loose because it has elements that are not defined in the definition of your vocabulary. So the cleaner way is to use some ad hoc, basically make inclusion part of your XML vocabulary. Okay. When it comes to the API that we're going to talk about later, I'm only concerned with core XML and namespaces. I'm also going to mention which existing libraries support which standards from the useful list. Okay. Right, how many of you tried to write your own XML parser? Okay, quite a few. And how many of you actually went and checked in the spec what it takes to write a conforming XML parser? Oh, we actually did. We actually
I checked, and that was the end of it.
And that's when you stop. And that's when you stopped writing the parse. Wise choice. So here's an XML file that uses all of these features, and this is what your application should actually see. So chances are pretty good that the parser that you write for fun over the weekend is actually not a real XML parser. Now, some of you will say, well, you don't really care about all these CDatas and DTDs because anyone who uses them in your company gets fired on the spot. And I would agree with you. We should stay away from most of them most of the time. But remember, we use XML as a data interchange format. While the documents that you produce may never use any of these features, it's only a matter of time before someone sends you a perfectly valid XML document that your application won't be to handle, and most likely not in a good way. If you go to a lot of the new libraries that don't really implement the conforming, that are not really conforming, they don't tell you what happens when you try to parse something that they don't support. So who knows what will happen. Okay, so my suggestion is don't push yourself into a corner. Use a conforming XML parser. There are plenty of fast and conforming implementations out there, and I'll mention quite a few when we talk about existing tools and libraries. Okay, let's also quickly discuss existing XML processing models and APIs. Most natural is in memory. That is, the document is parsed and its representation is in some form is constructed in the application's memory. Most commonly used in memory API is DOM, or document object model. DOM represents documents as a tree of nodes, with the root being the document node, and subnodes can be element, text, and so on. Here's an example of this is a sample document and the corresponding DOM layout. I'm sure most of you have at least heard of DOM. The main advantage of the in-memory model is that all the data is accessible all the time. This is also the source of its main disadvantage when it comes to handling large XML documents. The in-memory representation may consume too much memory or not even fit in memory at all. Plus, there's a performance cost for building this in-memory representation. So the alternative model, any questions about? If you have any questions, then feel free to interrupt. Yeah, I'm sure most of you know most of this. So the alternative model is streaming. When the document is being parsed, the application receives the data as a series of parsing events such as start element, attributes, text, end element, and so on. Similarly, during serialization, the application delivers the document as a series of elements, attributes, and text. The streaming approach is usually significantly faster and requires a lot less memory than the in-memory model. Its main disadvantage is that we only see a small portion of the data at a time. As a result, we often have to cache some of it for later processing. When it comes to streaming parsers, there are two further choices. A parser can use the push model or the pull model. Push parsers call us when the next event is ready for processing, while the pull model, we call the parser when we are ready to handle the next event. In other words, push is callback based and pull is iteration based. The most commonly used push API is SAX, or Simple API for XML. There's no really established pull API. There are also hybrid, partially in-memory, partially streaming parsers and serializers that try to deliver benefits of both models without any of the drawbacks. In this model, the idea in a nutshell is to use streaming approach up to a certain depth in the document structure, at which point we switch to the in-memory representation. The result is a document that is being parsed or serialized in chunks. As an example, let's say we have a people catalog with a large number of person elements that we cannot possibly expect to load all at once into memory. So what we can do is use the streaming model up to the person element depth, at which point we switch to the in-memory model to handle each individual person. Well, the best XML API is the one that you don't have to use, right? And that's exactly what XML data binding tries to achieve. Instead of making you deal with elements, attributes, and text, XML data binding goes directly from XML documents to C++ classes. So for example, instead of looking for an element called age, getting its text content and converting it to an integer, you just call the member function called age, and it returns you an integer directly. XML data binding can also be in memory, which is the most common, and streaming and hybrid. And for really large XML vocabularies, it can save a lot of tedious mind-numbing coding. Okay. Let's now see briefly what is available for handling XML in C++. As you can probably guess, a lot of the new claim to be either super fast or super compact or header-only XML libraries for C++. They take shortcuts and as a result are non-conforming. In fact, any new parser that pops up is an immediate suspect in my books until it's tested conforming. So I've divided all the libraries into two groups, real and not so real or subset parsers. Not really, well, since I don't recommend using, I only recommend using real XML parsers. I'm not going to cover any of the subset parsers. And I'm also only really interested in open source, reasonably portable projects that are still alive. Okay, so let's start with Xerxes. This is going to be fun. Xerxes is an Apache project. What I'm going to say next about it might sound harsh, but in my defense, I've been a developer or more like a maintainer for a number of years now, and I was largely responsible for whipping the last two releases into shape. If I have to sum up the Xerxes mod philosophy, it would be, let's build an enterprise-grade XML parser for C++. The result is an overly engineered, non-idiomatic API with brain-dead memory management and code base that will make your eyes bleed. But, there's always a but, right? But it is probably the most complete and mature XML library for C++. And it's the only one with working and tested XML schema implementation. So if you need XML schema, unfortunately, you don't have many options. libxml started as the XML library for the GNOME project. If I have to sum up its motto in one sentence, it would be, let's do object-oriented programming in C. The result is not very pretty. It also doesn't have a working XML schema implementation, and it has some heavy dependencies, such as glib. Question, yes? Yes, I think they have an implementation with relax and G, which is, oh, sorry, the question is, doesn't libxml support validation with relax and G? And the answer is yes, I believe so, and the relax and G is an alternative schema language which nobody uses. So. Well, I have people who use my tool who actually convert their relax and G into XML schema automatically just to be able to, use tools. Okay, we have another question. Yes, Sebastian. Okay. So Sebastian checked for us, and yes, libxml supports relax and G. Okay, XPath. XPath is a small and fast, low-level XML parser with a C API. It's probably the most commonly used XML parser if you consider how many scripting languages as well as mobile and embedded systems use it underneath for their XML APIs. So if you're looking for a really fast and conforming XML parser, XPath is probably your best bet. Okay, so there's Qt. Of course, it has its own XML parsing module that implements SAX and DOM, and which, according to documentation, is no longer actively maintained. And the recommended way for parsing XML, well, handling XML in Qt, is to use the pool parser and streaming serializer from the core module. The parser is said to be a conforming XML1 or non-validating parser. It's actually pretty functional if you can look past some of the Qtisms. Okay, XML data binding. Well, the first two, there are quite a lot of open source options for languages such as Java or .NET, but there are not that many for C++. The first two tools are the ones that I'm working on, so I'm obviously biased here. So I'll just run quickly through just to give you an idea. XSD is a general purpose XML data binding toolkit for C++. It's fairly powerful and mature, has some pretty advanced features such as the hybrid model, the support for polymorphism, binary serialization, and the ability to customize the generated code. XSD was specifically designed for mobile and embedded systems. It's a lot more basic than XSD, but is extremely portable and compact, can work without exceptions, STL, and so on. XML Plus is a relatively new project. I had a hard time finding much information on it. The XML schema support seems to be very limited, and they claim that they've built a custom validating DOM parser on top of XPath. I went to check the validation code and I wasn't really convinced, but you can check it for yourself. Okay, let me also mention yet another way of making your application handle XML. There are libraries, most notably Boost Property Tree and Serialization, that will read and write XML for you. The main problem with this approach is that these libraries don't really give you much control over what the resulting XML will look like. Well, Boost Property Tree gives you a bit more control, Boost Serialization a bit less. And remember, we are using XML as a data interchange format, which means we probably want to document it and specify it or formally define it so that third parties can actually interoperate with us. So control over the XML vocabulary is normally something that you would want. Question, yes?
Just as a comment, I would say that arguably, Boost serialization can have an archive type written for it that would customize it. But I would say that it's a non-trivial thing. So, in other words, obviously there's an out-of-the-box XML that's supported, but that doesn't mean your application has to be limited to that. You could write your own archive type. But that's a lot.
Okay, so a comment was, Boost Serialization library actually allows you to write a custom archive where you can customize the look and feel, I guess, of your XML. But it's quite a lot of work. Yes, question?
All you're doing is outputting that XML. You're not parsing it really. What are your does that affect a lot of this and make it a lot easier, or they're all written there?
You mean the existing libraries?
Yeah.
So the question was, if you just write XML and don't really parse it, does it make your life easier or any of the tools mentioned more suitable or less suitable? It is a lot easier to write conforming XML than to parse it, so yes. In fact, a lot of people just use print statements to output XML, which is, I think, a bad idea, but no dependencies in return. Most of these libraries have serialization handled pretty decently because it's an easier task. Okay, any other questions? Oh.
Partially in answer to that question, part of the motivation for adding raw string literals to C++ 11 was to make it easier even to write. Use regular C++ IO create.
Okay, so the comment was that part of the reason for adding raw string literals to C++ was to make something like that easier, that is to kind of write XML directly.
Of course, the other one was to make it easier to write real expressions.
Yeah, those are the two primary uses.
Well, and for completeness, the second reason was to make writing regular expressions easier. Okay. So we have a pretty good understanding of XML in general by now, I hope, and in C++. So which processing model, which API, and which library should we use? Well, the answer is, as usual, it depends. Depends what your application needs to do. So let's now try to understand what the typical XML usage patterns are for real C++ applications. Note here that I'm not really interested in outliers. If you are writing an XML editor, your needs are not common. Also, I assume we use XML for its intended purposes, and that is as a data interchange format. So the past 10 years I spent helping people deal with XML and C++. Admittedly, most of my cases were on a more difficult side, but plenty of people use XSD for simple things like storing configuration formats. So what is XML normally used for in C++? You might be surprised, but there's not much variation. Here's the list. The two of these items are very common, while the other two are quite rare. Can you identify which one is which? Yes, so you got the right answer. So the first two are very common. The other two, and especially the last one, are quite rare. Object persistence is just a label for data that describes stuff. Configuration formats, test setups, game scenes, financial transactions, building cities, and so on. You would be surprised how many of these domains are actually defined formally in XML schema. I'm sure most of you also have seen XML used for messaging. Sometimes C++ used to implement XML converters and filters, especially where speed is a concern. Do you think I missed anything? Can you think of a use case that doesn't fit into any of these? Yes, we have a.
Certainly the last few places I've worked, config files could be working central. The structure of what's in the config file is just as important as within. So thinking around an application as what services.
Okay, so the comment was that the configuration files might actually be document-centric because the order of things are quite important. It's a bit fuzzy what the distinction between document-centric and data-centric. And usually the good way to define it, does your XML vocabulary have mixed content? Do you have text mixed with elements in your config files? And I would expect that the answer is yes. So you have some text and then some elements going right after it. Okay, well then you have a document-centric configuration file, something that I've never seen. But we will see, choosing and designing an API, we don't also want to lock ourselves completely out of the kind of other use cases. So you will see that in the end you can handle the document-centric vocabularies using the API. But in my experience, document-centric vocabularies are a lot less common than data-centric. Any other use cases anyone can think of? Okay, so just to keep things interesting, we'll concentrate on the first three usage scenarios. And the last one will actually kind of cover document-centric vocabularies, as you will see in a sec. So we now have a pretty good idea what XML is used for in C++ applications, kind of in broad terms. So let's now see how that translates to the various aspects that we've discussed. So now we are coming to your question. So other commonly used vocabularies, data-centric or document-centric. For persistence in messaging, they are almost always data-centric. For filtering and conversion, it can be either way, but filter or the converter normally doesn't care, what kind of data it deals with. This also gives us another useful insight, and that is there's not much mixed content in the documents that we are going to handle. This is actually quite important to keep in mind when trying to design a convenient API, as we will see later. Okay, so we have an idea of what the typical C++ application uses XML for. Can we, okay, we have a question.
What exactly do you mean, say, mixed content? Like we're just talking about
Okay, let me just,
side by side, but can I see what that would look like?
I will show you. I think we have a bit of a confusion. This is mixed content. So the question was, can I clarify what exactly mixed content looks like? And here it is. So we basically have text, some nested elements, some more text, some more nested elements going kind of intermixed. So think of it XHTML, right? You have some text, some paragraphs, some more text inside. So a question for the audience. So you are saying that your configuration files look like this?
Yeah, but they contain multiple types of
Interesting. So there are apparently configuration files that look something like this. Very interesting. Okay, where were we? Okay, so we are trying to decide which processing model we should use. And remember, the two choices are essentially in memory and streaming. Well, there's kind of a hybrid model in between. This question is actually a bit harder to answer. And to answer it, we need to understand what a typical application actually does with the data stored in XML. And you'd probably imagine that things are quite a lot less typical here. But let's just try to write a list and see how we go. Well, we could load a state of C++ class from XML, right? Or we could compute something based on the data stored in XML without creating any kind of in-memory representation whatsoever. Or we could convert or filter the document without really understanding anything about the data. For example, we could sort all the attributes to be in the alphabetic order. Not that many options. Anyone can think of anything that doesn't fit in here? Let me discuss the first two options in a bit more detail. It's actually not just two kind of points, but rather a spectrum. On one end, we would have C++ classes that know how to persist themselves into XML. Okay, we have a question.
This might be an alternate, but the direction of quotes, does XML allow for parsing the three different quote styles? Or so they're like left quotes?
No.
Yeah, I was just wondering if that was a power.
Well, that's actually LaTeX. So.
Okay.
But yeah, I guess good point. If you copy it and paste it into an XML document, it'll probably not parse. So the comment was that these quotes actually are not valid in XML, this form of funky quotes, but that's what LaTeX does. So. Okay, so we have at one end of the spectrum we have C++ classes that know how to persist themselves in XML. Let's say we have this vocabulary which identifies the position of an object as a series of parsing as a series of position samples. So our corresponding object model might contain the object class and the position class that know how to save themselves into this XML. On the other end of the spectrum, we have an application that computes all it needs without storing any of the data whatsoever. For example, we might be interested in the average positions. Once we calculate that, we don't care about any of the individual samples. And somewhere in the middle, which is probably the most common case, or quite common, we will have an application that does both compute something based on the XML data and creates an object model based on the result of this computation. For example, while our vocabulary contains samples of positions, our object model may only capture the average position. So the parsing code will compute the average and instantiate the object model using this result. Okay, so we know what a typical application more or less does or can do with the data. Which processing model should we use? Now, most people, for some reason, think that they need in memory. If you look at all this new claim to be super fast XML parsers, most of them have a in-memory DOM-like API. I don't believe this is because in-memory is conceptually better, but rather because of the really awful and inconvenient streaming APIs. So today, I'm going to try to convince you that streaming is actually enough for most cases. And of course, there will always be some applications that need to revisit the bulk of the raw XML data, and for them, in-memory will probably be the best option. But as I mentioned at the end, it's relatively easy to go from streaming to hybrid or full in memory, while not so easy to go the other way around. Okay, so with streaming model, we have two further choices: push and pull. Remember, the push is the parser tells us when it's ready, and with the pull, we tell the parser when we are ready to handle the next parsing event. If we want convenience, then push with its inversion of control and callbacks is really awful. If we want speed, then push is normally a bit faster. I say we trade extra speed for convenience, and because if it's the maximum speed that you're after, then choosing XML was probably the bad idea in the first place. Yes, question.
There are some organizations out there that stream real-time financial data through XML.
So the comment was that there are actually organizations that still stream financial data in real time in XML. And could be one of the reasons why they do it is because there is a huge standardized format that all organizations kind of adopted, and there's it's defined in XML schema, so you know it's kind of more or less formally defined. Yes, we have another question.
I had a format that I was a while ago where we ended up with many simultaneous XML documents being streamed to fragments at a time. And so starting up a thread for each parser really was not having something blocked by quality. And that happened something that didn't let me add more data to each parse later. It didn't require me to be able to stream all of them. Those were massive requirements. As a result, have all of them.
Okay, so the comment or more an example of kind of sick stuff that you see in the XML world is that there was a stream of several documents that were interleaved, like chunks of the document were interleaved in the same stream, and kind of starting a parser in a separate thread was not an option because you still have to kind of handle somewhere this interleaving, I guess we would call it. Yeah, with a lot of things like that. Okay. So here's the summary of the API that we want. And we are finally ready to see some code. I think that's what you all came here for. I'm going to expose pieces of the API and show the examples as we go along. So here's the parser and serializer. Remember the 3 common use cases for XML that we discussed earlier. Converters and filters normally require the lowest level API with a minimum overhead. So we'll start there. That's where you can also parse all kinds of mixed content stuff. When designing this API, I try to make things as self-explanatory as possible because I hate writing documentation. So in other words, I want you to look at the code and think, and I expect you to think, wow, that's exactly how it should be, rather than, wait a minute, why on earth did you do that? But if something is not clear or if you disagree with the design choice, then feel free to interrupt. Okay, so we have the constructor for the parser. The first argument is the stream that we are parsing. The second argument is the name of the document that is used in diagnostics. And the last argument is the list of features list of the parsing events that we want the parser to report to us. Okay, we have a question. Yes?
Was there a reason that you used unsigned short for that? Or is this like is this supposed to be like bit flag on and off kind of thing?
So the question was, why did I use unsigned short, and if it's a bit flag? And the answer is, yes, it is a bit mask, and I use unsigned short. Yeah, so you kind of combine them with an OR operator. You can see.
Why unsigned short as opposed to different standard bit set?
Easier and simpler. It works, in C++ 98. Why? I know if something does the job, why kind of complicate it? So that's my philosophy. So unsigned short seems to work pretty well. I don't know, does it answer your question? And it's, why say unsigned short instead of unsigned in? Well, because everything fits into unsigned short so far, and I hope it will stay that way. I don't want to have, more than 16 of the parser features, but might have in the future, who knows. Okay. All right, so as an example, let's write a filter that removes a specific element, attribute, from all the elements in the document. So the first thing we do is create a parser instance. Okay, so far so good, right? Pretty easy stuff. Okay, the next chunk of the API. I'll just let you check it out. So we call the next function when we are ready to parse the next event. So we can write our parser a bit more, write a bit more code for it. Again, should be more or less self-explanatory, I would say. In C++ 11, we can use the range-based for to tidy this up a bit. So while it doesn't really kind of feed the iteration model, this interface, I provided a really limited iterator support just to make the range-based for possible, because That I think looks pretty clean. Okay, the next piece of the puzzle. You have the name function, which returns the name of the current attribute or element. And the value function returns the text content for the characters event corresponding to an element or attribute. The line and column functions return the current position in the parsing position in the document. Okay, question?
On the string name value, is there any assumption or requirement on the encoding of the string in GFA? Is that just an application?
No, that's well. Let me put it this way: in the implementation, it's always UTF-8. So the application encoding is UTF-8. Sorry, the question was: is there any specification on the encoding of the data that is returned by the not really only the value function, but all the functions that return, like attribute names and everything. So, and the answer is the encoding, the application encoding is UTF-8. Okay, question?
So why are you using set string instead of some form of string view?
So the question was, why do I use string instead of some form of a string view?
It's not backed by string. But this is
I guess I could see some benefit. Yeah, I could see the benefit of doing that in the sense that this interface will allow more options when it comes to the implementation. So, you know, if something like this goes into the standard, then that would be a valid question to ask or to think about. But currently, that's where I store the text in the implementation. So I just return it. But yeah, I think it's a valid question.
You're putting in dependencies and not going yes, yeah.
Right.
well, I mean, like,
But
it's a fairly simple class.
So standard pair. No, it isn't.
okay.
String wrap, yeah.
Yeah, it kind of all depends. You know, I just have one implementation of this interface, and it just makes sense. But yeah, once you start thinking about different possible implementations, it's a valid concern. Okay, so we can use these two functions to, for example, print the positions of all the elements as we parse them. Also pretty straightforward, right? Okay, we've actually seen enough parsing side to finish our filter. We're surprised. Nobody's surprised. Okay, good. So let's now switch to the serializer side. The construct is pretty similar to the parsers. Again, the stream, the name. The indentation argument specifies how many spaces, indentation spaces should be used for pretty printing. You can pass 0 to disable it. Of course. The question was whether is it spaces instead of tabs? Not tabs. Okay, so the next step then we will create the serializer. In the filter, we'll probably want to disable pretty printing because we want the kind of what is in the input to be in the output. Okay, the next chunk of the serialize API, again, I'll just let you kind of gaze at it, and I think it doesn't require any explanation. Okay, question?
What do you do if int element is called before an int attribute?
You'll get an exception.
Okay.
Sequencing, invalid sequencing. Okay, pretty clear. So now we can finish our filter. So this part deals with the loop here and the element parsing code. So nothing really interesting here. We just kind of forward everything to the serializer. And here we have a bit the rest of the implementation. Here we have a bit of logic for skipping the ID attribute. So that's essentially the skeleton for implementing a filter or converter using this API. Probably will fit on one page. Do you see any problems with this? Well, that's what we try to get to. Well, one problem is, sorry, the comment was that it's pretty low level, and well, that's the lowest level you get. One thing that is kind of broken here is that we don't handle XML namespaces. So let's see how we can fix that. The first problem has to do with element and attribute names. Those can be qualified when namespaces are used. So the API uses this QName class to represent such potentially qualified names. Then the parser API, in addition to the name function, has the QName function that returns the qualified name. And the serializer has overloaded start element, start attribute for the QName. Generally, anywhere where you see an element name or an attribute name in the API that I'm going to show, there is an overloaded QName version. Okay? I might forget to mention that, but just an upfront. Okay. So the first thing that we need to do to make our filter namespace away is to start using qualified names instead of the local ones. So that's pretty easy. We just change name to QName. There's another thing that we have to do. You see, now our filter doesn't propagate the namespace prefix mappings from the input document to the output, where our input might have meaningful names assigned to namespaces. Our output will have automatically generated ones such as G1, G2, and so on. To fix this, we first have to tell the parser that we want to receive the namespace prefix mappings, or namespace declarations as they're called in XML. Once we do that, then we need to propagate this information to the serializer. That's pretty much it. Okay, so no questions. So, there's a question. It's a keyword. So the sorry, yeah, maybe I should. It's fine. Yeah, it's late. So, okay, question. Yes. So the question was: is there an end namespace decal? Yes, there is one, but it's implicit. It's kind of scoped in XML, so we don't need to do anything for it here. In this case, but you can, if for example you're building a stack of namespaces yourself. Okay, another question? From a part. So the question was, how, in case of a filter, how would we filter an ID from a specific namespace rather than unqualified ID that we have here, correct? We would just, so what happens here is QName is implicitly constructed from this string literal, and it's an unqualified name. So instead of doing that, you will just create a QName with the two arguments, first namespace, second ID. So you see here's the constructor. You mean prefixes? Not in the names. So you see, prefixes in XML is a syntactic sugar, but you can kind of translate them back to prefixes. Okay, question?
How do you handle a default namespace?
automatically. So the question was how does the parser or serializer handle default namespace? It's not really any different than compared to the other. You just specify empty prefix or get back empty prefix, and that's the default namespace. Luckily, there's no special casing for it. Okay. So that was a pretty low-level XML work that we had to do. Once the main point about what we've done up till now is that we didn't really care much about what data is stored in XML or even which XML vocabulary we are dealing with. But once we start parsing a specific XML vocabulary and try to do something useful with the data, this API will become pretty painful. And the reasons for these are listed here. That would be, the first one would be validation and error handling, and attribute access, data extraction, content model processing, and control flow. So let's examine each one of these with using this object position vocabulary as a test case. Once you start parsing XML, you'll quickly realize that the biggest pain is validation and error handling. This stuff is pervasive. A root element can be spelled wrong, the ID can be missing, there can be some junk before the name element. Things can be broken in XML in an infinite number of ways. You know, as we've seen now, the quotes might be wrong. Here's just parsing of the root element with proper error handling. Doesn't look pretty. To help with that, the parser provides the next expect function. The idea is pretty simple. It gets the next event and makes sure that it is what we expect. If not, it throws an appropriate exception. Simple, right? So that's how we can use it. So now all that error handling is gone. If the root element is not the object, we will get a nice exception saying got this element instead of that's what expected. Okay, let's try to get the value of the ID attribute. Well, according to what we've seen, that the code will look something like this. Not too bad, except a bit thick. Now we have our object element has a single attribute ID, but okay, we have a question. I'm getting to that. So the question was, are the attributes ordered? And the answer is that that's exactly where I'm going. Currently, our object has only one attribute, but if we have several, then in XML, the order is arbitrary, which means we have to be prepared to handle them in any order. And that complicates our code quite a bit. If you think about it, it's actually not that convenient at this level of the API of the work to get attributes as events. Instead, what we would want is something like a map. Remember that I told you about this receive attributes feature? Well, I actually lied. There's no such thing. Instead, we have these two. So we can ask the parser either to send us attributes as events or as a map. In case of a map, we have the following API, attribute access API, to work with. If the attribute is not present, then the first function will throw an exception, while the second one with the default value will return that value. So now we can, so these are the two functions. So now we can parse the attribute quite easily. Okay, so we get an exception. Okay, question? So the question was, sorry, can you? Okay. Okay. So the question is, have I considered providing a function that returns something like optional so that we don't have to do the two name lookups, for example, call present first, and if it's there, then get its value. I haven't considered, but I think I should. Good point. Though, no, we are parsing XML. I'm not really concerned with this much. No, but yeah, I think it's a valid point. Maybe just return a pointer which can be not very C++ 11, but will do the job. Okay, I have two comments. So the comment was that we probably don't need this function. We can just use basically the one with the default value. And well, the reason why you might want to do that is if you need to compute the default value, and it's expensive, so you don't want to pre-compute it in case you don't need it. So there could be reasonable cases. Okay, question.
Correct me if I'm wrong, but I think when you find an element in the map, you get back a pair of buttons. That would be one alternate, more C++ issue.
To return a boolean and a pair. Yeah. So the comment was that one way to implement that function would be to return a pair similar to a map. Okay, another question.
So like the reason that map returns a pair is that the iterator always returns. You either inserted it or it was there. And whether you inserted it. I think for something like this, optional makes a lot more sense because it's there or it's not.
Good point. Yeah. Well, the comment was that it might actually not, the pair might not make sense because the value is not actually there. So we kind of return a default constructed string, which is kind of not very clean. Agree. Okay. So if the attribute is not present, we get an exception. But what happens if there is a stray attribute in our document? Well, the attribute map is a bit magic in that sense. At the end of the end element event for the object element, the parser will actually check the map and see if there are any attributes that haven't been retrieved with the attribute access API. If there is, then it will throw an exception. You can override this, but that's the default behavior, so you don't get unhandled attributes. Okay, so error handling more or less out of the way. The next thing that will start annoying us is data extraction. And for that, the API, the parser provides this data extraction API. Okay. Let me know if there are any questions. I think it's all good. No question? I'm going to get, the question was, how does it convert string to the value type, and I'm going to get to that right now. So using this API, getting the ID as an integer is pretty easy. Let's now try to parse the name. The name element. Here's the part of the document that we are parsing. What do you think? Is this going to work? Everything's fine with this code? Can anyone see any problems? Well, this is kind of the part that we are, this is as far as we get in the XML. Okay. Well, we're actually going to get an exception here. And if we try to print it, we'll get characters instead of start element. If you look at the mailing list of any XML parser, this will be the most common question. Why do I get characters when I clearly should get an element? Well, in fact, there are characters there. There is the new line and a couple of spaces that I replaced with hashes. Well, the reason why we get these white spaces is because the parser doesn't know whether they're significant or not. And the significance of white spaces is determined by the content model that we talked about earlier. Remember the mixed and simple and complex and stuff. So here's the table. Empty content, elements are not allowed, characters not allowed, white spaces ignored. Simple content, no nested elements, characters allowed, white spaces preserved. Complex content only allows nested elements with white spaces ignored, and mixed content allows everything in any order, everything preserved. Okay, so we can specify the content model, and the parser will start processing white spaces for us automatically. So here what we do, and this code works as expected. Even more importantly, once we specify the content model, the parser can do more error handling and validation for us. That is, if there are nested elements in empty or simple content, or if there are non-white space characters in complex content, we'll get an exception. So even less things for us to worry. So I think this is a pretty unique feature that simplifies things a lot. Okay, we have 2 questions. Okay.
End up specifying content multiple times while parsing the document.
So the question was, do you have to specify content multiple times when parsing the document? And the answer is yes, because each element might have its own content. And next question.
On some input sources that are shot full of errors, I would think that exception-based error reporting might be slow. Is that an issue? I guess that's the question. See what I'm saying?
So the question is, if we are parsing a lot of invalid XML, then the exception handling might not be fast enough, performant enough. And I would say, I guess that might be the case, but
It's not something you run.
no. Yeah. There's no really way to kind of recover and continue parsing. So I don't go into those areas. Okay, question?
This is my first thought.
Mm.
That you said that you actually use subfunctions. Why isn't that
Well, the question was why isn't content set in next expect? And yeah, you're basically reading my mind. I'm gonna move it to next expect in the next couple of slides. Okay, any other questions? Good, moving on. So this is how we can get the content of the name element. As you can see, there's quite a bit of more code compared to getting a value of an attribute, and also XML markup element markup in XML takes quite a bit more space compared to an attribute. So in this case, it would actually be wiser to make name and type attributes rather than elements. But if you are stuck with a lot of simple content elements, there is this helper API that will parse them for you in one function call. The first 2 expect that we handle the start element event ourselves. This is useful if you also have attributes in the element. While the last 4 will parse the whole thing from start to end. That's what we would use for our name and type elements. Very similar to attributes. Okay, I'm gonna go a bit faster, so if you're still reading or have questions, let me know. So that's how we can get the name element, pretty simple. For the type element, we would like to use this enum class. So I'm getting now to Sebastian's question, how do the extraction functions get to the conversion? So we write the code very similar to the name element, except here we use the extraction function, and this won't compile. the parser doesn't know how to convert the string representation to our object type, and by default it will use the IOStream extraction operator, but we can also provide XML specific conversions by specializing the value traits class template. So if you don't want to provide the IOStream operators, or if the values are different, you can go this route. Okay, the last part that needs to be handled in our vocabulary is the position element. The only interesting part here is to stop before parsing too far, because there could be several of them. To help with that, the parser provides the pick function, so we can pick into the next element. Okay, now getting to the question. Yes. Yes. The parse, so the question was, I guess it's a question, why is the parse given a parser and serialize is given a serializer? And the answer is, if you want to throw from this function because you couldn't convert, then you can get the position and all that stuff from the parse. Okay. So yeah, the only thing, as someone mentioned earlier, to improve here is to, as you can see, we set the content immediately after next expect in both cases, and that will be a pretty common pattern. So we just do it all in a single function call. And that's the whole parser for our vocabulary. I think it's about 15 lines of code. It's a production quality with proper error handling and everything. Okay, question? Well, the assumption, implicit assumption here is that we should have at least one position element. So this is enforced in this arrangement. So I go unconditionally into the loop and expect to get a position. If there is another position, then I go again. But if okay, the comment was that, if I understood it properly, is that we could have a function that we call and specify an element name, and it will return us a range that will lazily kind of parse until we don't see those elements anymore. Interesting idea. Yeah, something to think about. Yeah, that would be quite a bit harder to implement with a range. Yeah, so it's a pretty limited solution.
Is now the right time to ask what you just mentioned some things about the state of this, that is production quality code. Does it have usage?
I'll get to that, but I have 10 minutes, so I'm gonna rush a bit. I still have quite a bit of stuff, unless you guys prepare to sit a bit longer. But yeah, I'm gonna cover that. Okay, so also when I said that it's production quality, I mean that this code, it has all the proper error handling. You know, if you feed it junk, it will tell you, exactly where you are wrong. Okay, the corresponding changes in the serialize API, I'm gonna really go fast through that. There's nothing really interesting here. So again, calling start attribute characters end attribute is a bit tedious, so you can serialize an attribute with a single call. Similar with elements with simple content. Again, single call writes the whole element. Again, data conversion functions, similar mechanism. Instead of serializing strings, we can serialize value types, uses the same value trait specialization mechanism. Here's the serializer for our vocabulary. Again, everything fits onto a single slide. I think pretty simple and clear and clean. Okay. But as you can see, serialization is normally quite a bit easier than parsing. Okay, so we've seen how to extract data and process it without creating any kind of object model. So now let's look at the other end of the range of the spectrum that we've discussed earlier and consider object persistence. We will tidy our XML a bit, so we'll make type and name attributes. Generally, the API works best with idiomatic XML and will nudge you in that direction gently. So the object model for this vocabulary might look something like this. I've omitted some sensible constructors, accessors, and modifiers here. Okay, what I'm going to show next is what I believe is a sensible architecture for implementing this, but it by no means the only way. For example, we do parsing in the constructor here, while you might prefer to instantiate an object first, say with a default constructor, and then call a separate function to do the parsing. Nothing wrong with that. So that's kind of my preference of doing that. Okay, the immediate question that we are confronted with is who is going to handle the start and end element events? Do we do it inside the constructor, or do we make the caller responsible for that? Well, I say we make the caller responsible for that, and the main reason for going this route is because we might have several elements of the same position type. If we hardcode the element name in the constructor, then we won't be able to reuse the same class for all those elements. And the second reason has to do with inheritance, which we'll talk about later. So the position constructor is nice and clean. Nothing really interesting here, right? Simple. This is the object constructor. The only mildly interesting line is where we call the position constructor to parse the content of the element. As you can see, we handle the start and end elements. Basically, the caller handles them. Okay, I'm going to skip through these. The serialization is very similar also. Serialize attributes and the loop, nice and clean. What's not so nice and clean is the starting code that starts the parser or serializer. Basically, the code that the client writes. This is what we get, and this is what we want to see, right? Well, the reason why we get this ugliness is because we made the caller responsible for handling the start and end elements. It works beautifully in our object model, but not so nice in the client code. So remember, the main reason why we went this way is because we want to be able to reuse the same class for different element names. But if you think about it, it's not very common for the root of the XML vocabulary to also be used inside the vocabulary as a local element. In fact, I haven't seen anything like that. So what we do is make an exception. We say that the root object of our vocabulary handles the begin and end, the start and end of the element. This is the parser, and this is the serializer. The only mildly annoying thing about going this route is that we can no longer parse attributes in the member initializer list. But I think it's a small price to pay. Okay, so that's probably the most interesting part. So far we've had a relatively smooth sailing, but things get a bit bumpy here, and this is normally where the in-memory people have their day. Say we have this elevated object, which adds the units attribute to our vocabulary as well as the elevation elements, right? So it's basically a derived object. So the object model might look like this. Again, fairly straightforward. See, streaming approach implies linearity. We start element, we add attributes, we write nested elements, we end attribute, and so on. While in memory allows us to first add some attributes, add some nested elements, then go back and add some more attributes. And this kind of back and forth is exactly what inheritance often requires, and that's a bit of a problem for us. So let's see why. Here's the constructor for the elevated object. Here I went back to our original architecture where we make the caller responsible for handling the start and end of the element. That's the only way to implement inheritance. If you handle start and end inside the constructor, this whole thing falls apart. Okay, so let's see what happens here. We want to reuse the parser for the object, so we call the base constructor. That constructor will go ahead and parse its attributes and then goes and parses its nested elements. Then, once it returns, we try to parse more attributes. This is not something that a streaming approach allows. The way I fix this is by extending the lifetime of the attribute map until the end element event for the element. In other words, we can access attributes from in the map at any point when we are at the elements level. So this code just works magically. We have the same problem with serialization. If we try to write this straightforward code, here's what happens. We first call the serialize function for the object, which does its thing, and then we try to add the units attribute after we've serialized the nested location elements. This is something that we cannot do. So the way to fix inheritance in serialization is to split this function into two. One will serialize attributes, the other content. And the serialize simply calls them in the correct order. I bet you can guess what the implementation of the elevated object serialization will look like. So we just call the base functions. And the serialize looks exactly the same. And that's pretty much it for the API. Is the list of pretty unique, I believe, features that it has. Now I was going to ask you for feedback, but let me just get through the implementation section, and then whoever wants to stay over can ask questions, okay? Okay, so is this a fantasy, as Beeman asked, or is it a reality? It is something that I can actually use. I've just released yesterday a library, which is open source, portable, small and external dependency free. And anyone has any idea what's up with the name? We'll leave it as a mystery. So if you follow my advice, you should be pretty skeptical and immediately ask the question whether it's a conforming implementation or not. And the answer is yes, it is a conforming, non-validating XML 1.0 implementation. Now you should get really skeptical, because as we've seen, implementing a conforming parser and testing it is quite a job. And I actually didn't. This is based on XPath, which is very well tested. So the library includes XPath source code as an implementation detail. You can also use external library if you prefer. Now, some of you who are familiar with XPath might be wondering how I adapted the push interface exposed by XPath to the pull interface that we've seen earlier. Doing something like serialize, storing all the events in a vector, which would defeat the purpose, since we'll have a really weird in-memory implementation. So what XPath allows us to do, and not many people know about that, we can suspend and resume the parser after pretty much every parsing event. So that's exactly what this implementation does. Okay, anyone wants to ask the question? Come on, it's a valid question. Nobody?
How well does that perform?
Exactly. So So what's the cost of jerking expat like that, right? So that's the question. Well, the performance hit from suspending the parser all the time is about 35% of the expat's performance, which is not negligible, but not the end of the world either. On this 4-year-old laptop, I get about 37 megabytes per second throughput with all the name splitting and string construction and everything. Yes, the question.
How would that compare to some using expat directly?
Okay, so the question is how would that compare to using expat directly? And yeah, I was afraid of that question. A no expat, so basically, you know, static C functions with empty bodies, so which means they don't do any name splitting, they don't do any std string construction, nothing. So that no-op code runs about twice as fast. So we are paying about 100% for all the nice strings and interfaces. Yes, question? The question is, have I tried to use coroutines to implement this? And the answer is no. I haven't even that didn't even occur to me, and I don't know how it will really work with expat. I don't know. Maybe I should. Interesting. I should try that. I know, for example, that I cannot throw from expat handlers because I cannot assume that the C code in between was actually compiled with exception handling enabled. So, but yeah, something interesting to try. Thank you. It will be my next project. That will be pretty awesome. Okay, so parser uses expat. Serializer is easier to implement from scratch, but I decided not to do that either. And I use instead a small C serialization library that was initially written by Tim Bray, and I've extended and fixed it quite a bit for XSDE project. So the library is based on the mature XML parser and serializer, and it's been used in production in ODB for quite some time now. What's next? If you want to give it a go grab the source code. On building on Unix, configure and make. On Windows, we have project solutions for 9, 10, 11, Visual Studio 12. And the things is just relentless. It's just every half a year you have to make a new big question.
So, am I correct in assuming from the name that this is something you're going to propose to the standard?
Okay, so the question was based on the name, is this something that I'm going to propose to the standard? So Eric guessed what the name kind of implies. And the answer is, I'd like to. If people think that it's worthy. I don't know. Okay, question?
Something individual with every member of the standards. Where is their level of comfort for a given library? An XML parser serializer, I'm going to be pretty scared of it unless it's won out through Boost or some similar organization first and had it for years.
Usage.
People
Yeah.
use it. Yeah, I don't, to me, it's too complex to do a mental analysis.
So the comment is that the standards committee will probably be a bit weary uh, of standardizing something that hasn't been used in production, in the real world for at least a couple of years, and mainly because of the complexity. And I would agree with you, even though I'm using, implementing an XML parser from scratch, that's a crazy idea. So this one actually kind of sidesteps this problem by using a proven XML parser. But even if you look at the implementation, I said, well, I suspend the parser and after each event and stuff, but there's a bit more to it, and the code is actually, it's not terribly complicated, but it's not trivial. So I agree with you. Yeah. I think this needs a bit of usage.
Is that you're going to have, if it gets accepted in standard, you're going to have several people implementing from the specification, not necessarily using XML or
Right.
whatever. Maybe they will, but
Well, I think it's nice to have an implementation that, it's probably as permissive as you can get license-wise. So,
yes.
yes. It is in the sense that you can use multiple parsers from multiple threads, but you cannot use the same parser from multiple threads without proper synchronization.
Or it's as, let's say it's the rest of the same.
Yeah. Fair question? Seems to be dead. That's my first opinion as a project. But well, the question was, what's my opinion on Arabica? I basically just heard about it. I kind of, from the documentation, it seems that they wrap, they can wrap several XML parser implementations and provide the same API. But it seems, I think they only provide Sax and DOM, and I'm not really interested in either of those. So, yeah. I know of it, but I've never really looked into it. A question? Mm-hmm. Okay, so okay, so the comment was that it's probably a bad idea to make parser responsible for converting strings to value types and back and forth. And the thing is, I don't really do anything there. It's a 10 lines implementation. I just delegate it to the IO stream. If you provided the extraction operator, it will work for you. If it doesn't, then you will have to do something. But well, my answer would probably be if we had something like lexical cost standardized, then obviously I would use it.
Yeah, I guess I was thinking contrary, but perspective, immediate the data type is nice. Not having to wrap it up.
No.
Because otherwise you're going to have to write more lines of code. But you're going to trust flexible paths to do that?
No, I think the
Provide a parser for that. So you're not saying take that part away? Yeah, I know.
so no data conversion whatsoever. Well, well, my reason for having it internally is that an XML representation of something might be different than lexical cast, and asking the user to kind of do it at every point where they serialize or parse this value is not nice, and I would rather let them specialize an XML specific conversion class template to implement that. But I agree the default implementation, it would be nice if it called lexical cast rather than IST, maybe. Mm. But in case on serializer, I don't have any angle brackets. I just pass the value. So I got you there. Okay, any other questions? So yeah, there is the API documentation, which is basically the second half of this talk with a bit of expanded examples and a bit more text. And there are also examples for everything that we've seen. Plus, there's a few extra examples. One is the performance, which measures the performance of the parser on your machine. And there's, for Beeman, there's also a separate file that implements the expat no-op parser. So you can actually compare it to expat as well. And then there's the hybrid example, if anyone still wants to use in-memory model, that it shows how to implement the hybrid partially in-memory, partially streaming implementation. It's a bit, the in-memory representation is a bit simplified and doesn't handle mixed content and things like that. So it's a bit of an example, but can give you an idea. Okay, any other questions? Who's going to give it a try? Anyone? Cool. Isn't it? Yeah.
I would like to give it a try, but I suspect it will be after I get back from my first one. Like a month from now.
All right. Well, hopefully you'll fix some bugs. Yeah, the rapid XML is a non-conforming XML parser.
Yeah, we're using Rapid XML as well.
Yeah.
We're smart. The only thing is, we know that our XML is more form.
Yeah, it's kind of, you are cornering yourself. You know, you're saying today everything is this, but you know, tomorrow someone will come and say, oh, we need to parse that XML that those guys are providing for us. And that's where the trouble starts. Yeah, is it header or I think some of them are even header only, which is okay. No. Well, this library is dependency free, but not header only. But it's all implementation detail. You don't see it. No, you just have this library. It's part of the source. You can compile and use an external. So you don't see it. And let's say someone packages it for Debian, you know, or Red Hat, the package management will link to the external one, so you don't get the code block. So. Okay. Thank you.